Section 3.4. We're going to be graphing lines in what's known as slope-intercept form. Let's see what that means. We're given the equation y equals 2/3 x minus 4. It asks us to determine any 2 points on the line. Well, if I'm going to determine any 2 points, one of my favorite ones to find is always the y-intercept. To find the y-intercept, I plug 0 in for x. If I plug 0 in for x, I have 2/3 times 0, that's 0. And 0 minus 4 is minus 4. And I'll figure out one more point. Now the reality is I could plug in any number in the world that I like, but I'm going to be clever, and I'm going to plug in 3. And the reason I'm going to plug in 3 is when x is 3, y is going to be 2/3 times 3 minus 4. And the reason 3 is a clever number, I think of 3 as being 3 over 1, and I notice I can reduce my fractions. In other words, I picked the number 3 because 3 reduced and made my fraction go away. I'm left with 2 minus 4. 2 minus 4 is negative 2. That gives me 2 points on the line. Now it asks me to use those 2 points to compute the slope. Okay, we use our old formula for slope. Slope is, remember, slope has to have the y values on top and the x values on bottom. Rise over run. Rise is up and down, that's y. Run is left and right, that's x. Okay, that's going to be negative 2 minus negative 4 divided by 3 minus 0. Minus 2 minus negative 4, that's minus 2 plus 4, that's 2. And 3 minus 0 is 3. Now, notice the happy coincidence here. Our slope turned out to be 2/3, and 2/3 happened to be that number right there in the equation. You're probably not surprised about that. Well, maybe you are surprised, but you're probably not thinking it's a happy coincidence. Determine the y-intercept. We already determined the y-intercept, 0, negative 4. And again, this is not a happy coincidence. This number, negative 4, happened to be that number, negative 4, right there. And this is our whole point of this section. For a linear equation of the form y equals mx plus b, the slope of the line is m, and the y-intercept is 0b. We say this equation is in slope-intercept form. So notice this equation I gave you was in slope-intercept form. We had the y all by itself, the number in front of the x, that gave us the slope, 2/3. The number here gave us the y-intercept, 0, negative 4. Well, having y all by itself like this makes graphing equations very, very easy. Here's what we do. We plot the intercept. Then we use the slope, remembering the slope is rise over run. So if our slope is 2/3, that would tell us go up 2 and right 3. And here, for some reason, I wrote it 3 units to the right and 2 units up. Usually when I do it, I go the other way. Sketch the line. Okay, so if I had to graph the line y equals 2/3 x minus 4, I would begin by plotting the y-intercept. The y-intercept I determine from this number. It's 0, negative 4. And then I use my fact that the slope is 2/3. What that tells me to do is start at my intercept, and I can go up 2 and right 3. If I wanted to, I could do it again. I could go up 2 over 3. Now, the other thing I could do, remember that 2/3 is exactly the same as negative 2 over negative 3, because when I'm dividing two negative numbers, I get a positive. So instead of going up 2, right 3, up 2, right 3, I could have also gone down 2 and left 3. And sometimes that's helpful, depending on your slope. All right, well, that gives us plenty of points, I think. Grab our ruler, connect the dots, and we have a nice line. All right, let's take a look at the next one here. Same deal. It wants us to graph y equals minus 4/3 x plus 5. I start with my y-intercept. This number right here gives me the y-intercept. So this time I know my y-intercept is 0, 5. So I plot my y-intercept right there. Now, the slope is this number here. That's minus 4/3. This tends to bother some students. Sometimes what you need to remember is that to end up with a negative, what I had to have is one positive number and one negative number. So if my slope is written as negative 4/3, I tend to like to write it as negative 4/3 because that reminds me to go down 4 but right 3. So I start here, I go down 4, right 3. Puts me right there. And I could do it again. I could go down 4, 1, 2, 3, 4, right 3, 1, 2, 3. The other thing I could have done, I could have also written this as 4/-3. Because when I divide, one positive and one negative is still a negative number, which means I could have come here and I could have gone up 4, but the minus here would tell me to go left. So I could have gone up 4, left 3. The point is, when your slope is negative, that means one of your values is negative, but one of them is positive. And we know that when we have a negative slope, our line should be decreasing, so we should get a line that looks like that. Okay, I want you to do C and D. And I'm going to give you a little hint here. When you don't have a fraction for your slope, that's okay. Your slope is 3. You're going to think of it as 3/1, which tells you you're going to go up 3, right 1. This one, your slope is negative 2. Same deal. Think of it as negative 2/1, which tells you down 2, right 1. Alright, well now we're going to go backward. Now, it gives us the graph, and it wants us to come up with the equation. In the past, I gave you the equation, and you gave me the graph. Pretty much completely backward now. Well, it's really not as difficult as you might think. We're going to write our answer in the form y equals mx plus b. So we're going to begin by finding our y-intercept. And I see my y-intercept is right here. My y-intercept is the point 0, -1. But remember that b comes from the y-intercept. So without doing really much work at all, I can immediately see that my b number is -1. Now, looking at this graph, I recognize that this graph is decreasing, which tells me my slope is going to be a negative number. And here's typically what I do to find the slope. I simply find another point on the line, one that comes right at a crosshair. So I might pick this one right here. It comes right on right where the grid crosses. Now, to find my slope, I have two choices. I could recognize that this is the point 3, -2. So I could use 3, -2 and 0, -1. And I could use my m equals y2 minus y1 over x2 minus x1 formula. Personally, I think that's a little bit too hard. All I do is this. I start here and I go to there. If I start here and go to there, I have to go down 1 and over 3. That tells me my slope is -1/3. -1 because I went down 1, right 3. So here's my answer. -1/3 x minus 1. My slope is -1/3. My b number is -1. I simply plug them both in. Well, you're probably not surprised at this. There's a homework problem. Pretty much the same thing. Find your intercept, find another point, count, use it to find your slope. Alright, last thing we have in here are some special kind of pairs of lines. Let's take a look here. Graph the following equations on the same grid. What do you notice? Y equals 1/2 x plus 3. All right, I'm going to graph that one in blue. I start at my y-intercept. My y-intercept is 3. And then my slope is 1/2. That tells me go up 1 over 2. Up 1 over 2. And we'll play a game of connect the dots. There it is. Second graph, y equals 1/2 x minus 1. I'll draw that one in green. I start at my y-intercept. My y-intercept is 0, -1. My slope is 1/2, just like it was last time. I go up 1 over 2. Up 1 over 2. And I play a game of connect the dots. And what do we notice about those two lines? Well, what we should notice about those two lines is they are parallel. Why are they parallel? Well, they're parallel because they have the same slope and they had different intercepts. What does parallel mean? Parallel means two lines that never cross. Well, the way they're never going to cross is they're going to be going the same direction and they're going to have the same steepness. What tells us about direction and steepness? It's slope. So, lines are parallel. Well, they're both in the form y equals mx plus b. Lines are parallel when slopes are equal. Alright, let's take a look at number 5 here. Kind of the same deal, except this time I notice right away the slopes are not the same. This one's a 3/2, that one's a -2/3. Let's see what happens this time. I start at my y-intercept, it's 0, 3. I go up 3 over 2. So up 3, 1, 2, 3, over 2, 1, 2. Up 3, 1, 2, 3, over 2. And I connect the dots. Second one. My y-intercept is -1, 0, -1. This time my slope is -2/3, so I'm going to go down 2 and over 3. Down 2, over 3. And I'm going to play connect the dots there. And I should notice something special about these two lines. What I notice about these two lines is these two lines are perpendicular. Well, what do we know about perpendicular lines? The thing we know about perpendicular lines is they meet at what's known as a right angle, a 90-degree angle, and that's the symbol we usually use for 90-degree angle. But how do you tell when lines are perpendicular? Well, you tell by looking at their slopes. Notice that this one is a 3/2, and this one's a -2/3. Two things had to happen. First off, this one's positive and this one's negative. And that has to happen to be perpendicular, because they have to be going different directions. The other thing that happened is this one's a 3/2, that one's a 2/3. So we have the reciprocal. 3/2, flip it over. Fancy word for flip it over is called reciprocal. Alright, so again, if lines are written in the form y equals mx plus b, they are perpendicular when their slopes are opposite reciprocals. Reciprocals. I think that's how you spell that. Opposite reciprocals, which is a fancy word for one has to be positive, one has to be negative, and then the reciprocals, 3/2 and 2/3. Okay, so final questions. Number 5. Determine whether the lines are parallel, perpendicular, or neither. Okay, for A, to be parallel, the slopes have to be exactly the same. This slope is a -2, that slope is a +2, so they are not parallel because these slopes are not exactly the same. To be perpendicular, if this one's a -2, then this one would have to be the negative reciprocal. Since this one's already negative, it would have to be positive, and then it would have to be reciprocal. Since that's 2/1, this one would have to be 1/2. So, these are not parallel because the slopes are not exactly the same. They're also not perpendicular. To be perpendicular, if this one has a slope of -2, this one would have to have a slope of 1/2, but it doesn't. It has a slope of 2. So the answer to this one is they are neither. B, -2/7, -7/2. Clearly not parallel because these slopes are not equal. However, I think right away you would agree that these are perpendicular. This one's positive, this one's negative, so they're the negative thing, opposite thing. And then they are reciprocals. This one's a 2/7, flip it over, 7/2. Those two are perpendicular. All right, last two homework problems, B and D. Bring all these problems with you to class. See you then.